Good morning, grade 12 technical math learners. My name is Matsidiso Kongwani. This lesson is proudly brought to you by the Gauteng Department of Education. Please ensure that you have the necessary tools with you. That's your book, your pen, and your calculator with you, learners. You are all welcome to this special revision session. Our focus today will be on revision of Tech Maths, paper 1, since we will be starting with our final exam, paper 1, as we are writing our first paper on the 5th of November. And then the paper 1 topics that you will be examined on and their weightings are: we are having algebra, which is 50 plus minus in your paper. And then we have functions, which is 35 plus minus 3. And then we have financial mathematics, which is 15 plus minus 3. And then we have the differential, calculus, and integration, which weighs 50 plus minus 3. Those are the paper 1 topics, grade 12, and they are weightings of content areas. As you can see, algebra is in the middle. Therefore, remember, algebra is the mother of all topics because it is applicable throughout all the technical mathematics topics. All right. And then here we have the information sheet. Remember, in each and every exam question paper, at the back of your paper, you'll be having this information sheet. And then here we have tried to clarify which formulas are used in paper 1. So our first class, we have classified this into 4 classes. So our first class will be taking the first 2 rows. Those will be formulae that are applicable for algebra, functions, and graphs. And then we are having the second class, which is the formulae for financial growth and decay. And then as you can see that they have clustered up to the effective rate there. And then we have the third class, which is differential calculus class. And then the formula that we have is the first principle formula. And then now the last class where we are having the integration. And then we have all the rules of integration below that one. So basically, grade 12, these are the top formulae in your formula sheet. Therefore, they are applicable for the paper 1. Right. Let's start now with the first activity. We are on algebra. Remember, the algebra is carrying something like 50 plus minus 3 in paper 1. Our first question: in order to support a solar connector panel at the correct angle, the roof trusses for a building are designed as right angle triangle. So I will be highlighting that statement because it is now telling me I'm having a right angle triangle of 90 degrees as shown in the figure below. The rafter on the same side as the solar collector is 7 meters shorter than AC. That is another information that is talking to side AC. And then the AC is the other rafter. And then the base BC of the truss is 13 meters long. Now the question to address is, if AB is X meters, as given in the diagram there, and then express AC. AC is this side in terms of X. So grade 12, since we have indicated that we have the 7 meters shorter than AC, the solar connector is 7 meters shorter than AC. Therefore, our AC side will be equal to 7 plus X. And then remember, this is also in meters. That is all is expected from us for that particular question. Moving forward, 1.2, complete the following statement for the given right angle triangle. And then in this case, grade 12, we're supposed to have the BC squared is equal to the AB squared. And then yours was to fill in the missing one there. And then the question states that complete the following statement for the given right angle triangle. As you can see now, we have plugged in all the given information from the previous question or statement. And then now we need to complete the one that is given to us. And then as you can see that the BC side is the side that is opposite the 90 degrees. Therefore, that is our hypotenuse. And remember, the hypotenuse is equal, the square of the hypotenuse is equal to the sum of the squares of the two sides. Therefore, if we are having the AB squared, that means what is left there is the AC squared side. And then why are we doing this? Is because of the Pythagoras theorem. Okay, grade 12. Let's continue. And then hence determine the length of AB and AC. And we know that the minute we see the word hence, that means we are depending on our previous solution. And then remember previously, we've just concluded that the BC squared is equal to the AB squared plus the AC squared. And then we said this is because of the Pythagoras theorem. All right, then we can now start doing the substitution from the given information in the diagram. What is BC side? We are having 13 for BC, and then this will be BC squared since BC is squared there. And then the AB is given as x from our diagram. Therefore, we'll be having the x squared there. And then if you look at AC, we are given x plus 7. Therefore, AC you are x plus 7. And then this is all squared. And then yours is just now to simplify and remove the brackets from there. So if we are having 13 squared, that simply means you will end up with 169 this side, and then which is equal to the x squared. Removing the brackets here, you square the first term, that is x squared, multiply the first by the second by 2, so this gives us the 14x, and then square the last term, this will give us the plus 49, grade 12. And then from here now, we start transposing in order to end up with a quadratic equation. So we are going to transpose this 169 to the right-hand side. And then when you take this to the right, it will be added to that 49. And then on the left, we will be left with a 0, which is equal to, we are now adding the x squared plus x squared, which will give us the 2x squared, and then plus the 14x. And then the 49 minus 169 will give us the minus 120. And then we now divide throughout by a 2 to simplify our expression or our equation. And therefore, we will end up with the 0 this side, which is equal to now the x squared plus the 7x, grade 12, come with me, and then minus 120 divided by 2, that will be a 16. And then from now, we can now factorize this trinomial. We are looking at factors of 60. When you subtract them, they must give you a 7. Let's check grade 12. There we are. Okay, we will be having x and x there from the x squared. And then the factors of 60, we are going to have 12 and 5 as our factors. And then now look, the middle term is positive. That means the bigger number will take the sign of the middle term. And then now the 5 will be negative. So therefore, we end up with an x value that is equal to negative 12, or the x value that is equals to 5. And then now be careful, grade 12. If we talk the x, we are talking to the side. So there is no way that you can have the length of the side being negative. So we are discarding this one as not being the solution because it's indicating that x is equal to negative 12. So our final value of x will be equal to 5. That is the one that is applicable here. And then remember now, the question is not yet addressed. We were looking at the length of AB and the length of AC. And then what is AB? If we look into our diagram, AB is equal to x. Therefore, this will simply be equal to 5 meters. And then to find the AC, remember it was x plus 7 from the diagram. And then therefore, we are substituting in the value of x, which will be 5 plus 7. And then this is simply giving us our value of AC being 12 meters. Okay, grade 12, I hope we are still together. Let's continue to the next question. Okay, we have solved for x. We are solving for x there in each of the following. And then 2.1, we are having the 3x minus 5, close open bracket, x plus 2. And then this is equal to minus 13. And then where x is an element of the complex numbers. Okay, grade 12, keep in mind, there's a message there that is telling you that your x value will be a complex number. And then now, please work out. I'm giving you 1 minute to do that and check why are we having this message which is saying complex numbers. Okay, grade 12, let's see now how far did you go with this one. Remember now, you know that when you are solving the quadratic equations, we always ensure that our right-hand side must be a 0. And then in this case now, you are having bracket, but this is equal to minus 13. There is no way, grade 12, that you can say the 3x minus 5 is equal to minus 13. We can't do that. With quadratics, before we solve, we ensure that everything is transposed to the left. On our right hand side, we are having equals to 0. Let's see. Removing the bracket now, we are having the 3x squared and then 3 by 2, that is plus 6x, and then the minus 5 by x, that is minus 5x, and then the minus 5 by 2, that will be minus 10. Then we are transposing the minus 13 to this side, that will be the positive 13 equals to 0. And then now from here, grade 12, we can now check our like terms. So 3x squared, you are the only one. And then the 6x minus 5x, we end up with an x. And then we have the minus 10 plus 13. 13 minus 10, we know that this will give us a 3. And then which is all equals to a 0. And then we can now use quadratic formula. You know that we can use quadratic formula throughout our factorization. Grade 12, you are more than welcomed to use the quadratic formula. Don't stress about factors if you are not comfortable about a short way of determining it. You can use your quadratic throughout. Let's take quadratic. That is x equal to minus b plus minus the square root of b squared minus 4ac, and then everything over 2a. And then the substitution part, remember the coefficient of x is the value of a, and then we are having a 1 there, and then that will be the b value, and then we have our c value there. And then this is minus a. What is a? What is b? Sorry, that is minus 1. And then we have plus minus the square root, repeat, b, 1 squared minus 4. And then the a value is 3. The c value also 3. The division line must close everything in the root sign. And then we are having 2 into 3 denominator there. And then grade 12. After this, please ensure that you have your simple set form. So this will give us minus 1 plus minus the square root of minus 35. And then everything over 6. And then now can you see that we are having the square root of minus 35? That is where now we are bringing in what? The complex number, since the message that x is an element of complex numbers. Therefore, now let's apply our complex numbers, technical mathematicians. Okay, that will be minus 1 plus minus the square root of, we know that if it is minus 35, we are going to say 35 multiplied by the negative 1. And then everything over 6. And then this is creating minus 1 plus minus the square root of 36 multiplied by the square root of a negative 1. And then over 6. So this brings us to minus 1 plus minus the square root of 35. We know that if you're having a square root of a negative number, so we are going to bring in the complex I, and then over 6. Grade 12, that is what is expected from us. Our answer will now be in the form of complex numbers, since we have the square root of a negative number. Okay, moving forward to the next question. Here we have to solve for x in each of the following, and then we are having the 4 minus x, first bracket. The second bracket is x plus 3, and then that is less than 0. And then this is not an equation anymore. Look at that, we are having an inequality sign. Therefore, we are solving an inequality, grade 12. And then if it's an inequality, that means our way of solving equation will differ now with the one that we are going to apply here. So when you are solving inequalities, number 1, as you look at the bracket, you can see that these have already been factorized for you, but we are having a challenge now because our x is negative. So we need to deal with that x. We are going to multiply that bracket with a negative, so that when we multiply with the negative, the x will become positive. I am also rearranging this. And then the 4 that was positive will now change to negative 4. With x plus 3 will remain. And as I'm multiplying by negative now, it is having an effect on my inequality sign. It was less than, it will now change to greater than 0. That is the new equation that we will be working with. And then now we can now grow critical values. So our first critical value will be x equal to 4 from the first bracket, or x equal to negative 3. And then we have different methods. Others are using table method, others the parabola function, others the number line. And then let's go number line, but use the method that you are comfortable with. And then now we are comparing the critical values. We have 4 and minus 3. We start by taking the smaller one first, which is minus 3, followed by 4. And then we look at our inequality sign. It is not having an equal sign. It is just only greater than 0. If that is the case, therefore minus 3 and 4 will be excluded from our solution. Hence, we are indicating that with an open dot there. And then the shading of our number line will be greater than 0. So if we are shaking greater than 0, we shade out grade 12, as you can see that, and then that means there's a space in between there. So our x values will be separated. In this case, we'll be having 2 x values now instead of 1. Okay. And then the values that are going this way are the ones that are less than. Then this will be less than which value? The minus 3 value. This way we are going greater than, and therefore x this side will be greater than which value? The value of 4 there. So that is how we solve our inequalities. And then remember, you cannot give me this inequality solution before you indicate the diagram that is predicting the solution. All right. Okay, let's move on. Okay, we are having a log activity there. And then it says solve for x in each of the following. And then the first one, we are having the log of 32 base x plus the log of 4 base x minus the log of 16 base x equal to the log of 125 base 5 now. And then remember, grade 12, you have to solve for x. Okay, and then let's do it together. We are having different ways of doing this, grade 12. Please use the one that is suitable for you. All right, and then now I am giving you 2 minutes to go through this. Apply your own method, the one that is suitable for you. 2 minutes, your 2 minutes starts now.
Believe in yourself. Believe a little more in yourself, because to those that believe, nothing is impossible. You have done this before. You have passed your tests before. You have went into a higher grade before. It is possible because you have done it before. Do not doubt yourself. Keep believing in yourself. Keep pushing, because this can be done and you can be great. The road to success is to commit to yourself. In order for you to become who you want to become as a student, you need to commit to reading your books, to studying, to bettering yourself. I know it's not going to be easy. Actually, no one said it's going to be easy. But if you put in the work, the results will show in your life. Tap into your power. Sometimes you will feel like putting away your books, and not reading as much as you're supposed to be. But I want you to commit, because through commitment, there is infinite power.
Dreams. What is your dream? Yini iphupho lakho? Not your parents' dreams, not your mom's dream for your life. What is your dream? Is it to get a bursary? Is it to study science? Is it to become a DJ? Is it to become a singer? What is your dream? Iphupho lakho. Once you have that dream, what I need you to do, I need you to write it down. Ingole mofati. Write it down, ibhale phansi, and read it each and every single day when you wake up. Read it each and every single day before you go to bed, and remind yourself of where you want to see yourself. What is your dream? Write it down, meditate on it, and go after it with everything that you have. Dreams. What is your dream? Yini iphupho lakho? Not your parents' dreams, not your mom's dream for your life. What is your dream? Is it to get a bursary? Is it to study science? Is it to become a DJ? Is it to become a singer? What is your dream? Iphupho lakho. Once you have that dream, what I need you to do, I need you to write it down. Ingole mofati, write it down, ibhale phansi, and read it each and every single day when you wake up. Read it each and every single day before you go to bed, and remind yourself of where you want to see yourself.
Okay, grade 12, our 2 minutes is now over. Let's check how far did you go with this one now. We said anyone can apply the method that is suitable for him or her, all right? Let's start now with the first way of solving this. Number one, particular learner can see that applying the rules of logs, if you are adding, you multiply, and then if you subtract, you are dividing, since we have the same basis on the right, all right? Our base is x. So now let's start with learner 1. This one will be having the log of bracket 32 times 4, and then since there's a minus, that will be divided by 16, and then we are having the base x there. That is our left hand side. And then on the right hand side, the learner will be raising this to log 5 to the power 3 with base 5 there. And then this gives us now the log of 8 base x. And then on the right hand side, you are having 3 log 5 base 5. Okay, and then this is log 8 base x equal to, remember, the log 5 base 5 will give us a 1. Therefore, we are left with only 3 that side. So now 8 will be left there, and then x back to its exponential form, it will be x to the power 3. Okay, grade 12. And then this side loses a cube, and then this will gain that as the cube root of 8. Therefore, our x value is equals to 2 in this case. All right. And then another learner alternatively might use the method that is raising everything into base 2. Check, we are writing now, rewriting the logs on the left with the base 2. So if you are having log 32, remember 32 is 2 to the power 5. So we will end up with 5 log 2 base x plus. Remember, f4 is 2 to the power 2. And then this one will give us a 2 log 2 base x. And then 16, remember, is 2 to the power 4. Then this one will give us a minus 4 log 2 base x. Therefore, still equal to the 3 log 5 base 5 that we've indicated on the left there. And then here we are adding the same logs. Look at this, we are having log 2x being common there. We can take it out. Log 2 base x as a common factor. So for the first one, if we take out log 2 base x, we'll be left with 5. Take out log 2 base x, left with 2. Take out log 2 base x, left with minus 4. And then therefore on the right hand side, we are only left with the 3, since the log 5 base 5 is equals to 1. Okay, grade 12. And then now let's continue. We are having a log of 2 base x, and then this will give us in bracket 5 plus 2, which is 7, minus 4, that will be 3, equals to 3. So we are having log 2 base x multiplied by 3, that is 3 log 2 base x equals to 3. Divide both sides by 3, the 3 will cancel a 3. We are left with log 2 base x equals to 1. Back to its exponential form, leave 2 this side, and then now we are having x to the power 1. Same answer as the one that we found on the previous application. I hope we are still well, grade 12. We are still together on this application. Both covered. All right, moving on. Question 3. The following formula represents the relationship between the capacitive reactance frequency, and capacitance. And then that is the formula XC that is given to us there, equal to 1 over 2 pi F times the C capital. And then the X base C is the capacitive reactance, which is in ohms. And then F is for frequency in hertz. And then C, the capital C is for capacitance in farads. And then express F as a subject of the formula now, grade 12. There is our F there. And then we need this to be the subject of the formula. Easy, grade 12, we are just going to cross multiply this to that side. So we will end up with F and the XC equal to 1 over 2 pi, and then the C that is left, because F is being cross multiplied. And then remember, we don't want the XC, we want F. We are also going to cross this XC to the denominator there. Then we will be having F is equal to 1 over 2 pi capital C, and then with that capacitive reactance C. Okay, so that is the formula in terms of F. That is all is expected from you, grade 12, just the cross multiplication from there. And then the 3.2, hence, if it says hence, it says use the previous conclusion now. And then to determine the nearest integer, the numerical value of F in hertz, if XC is given now as 63.66 ohms, and then the C, capital C for capacitance, is 50 times 10 to the power minus 6 farads. And then now, grade 12, since it says hence, it indicates to us that we are taking the previous formula that we have just created. Remember, that was F is equals to 1 over 2 pi C with the XC. And then let's just substitute now. We are having 1 over 2 pi. And then our capacitance is given as 50 times 10 to the power minus 6. And then multiply by the capacitive reactance, which is given as 63.66 ohms. And then grade 12, you just put this into your calculator, and then straight to the answer, it will now give us the frequency of 50 hertz. Okay, grade 12, I hope we are still together. Okay, moving forward, we are now going to look at the simultaneous equations. As you can see, most of your equations are given in diagrams, technical mathematicians. And then you have to predict what is happening in the diagram in relation to the formulae that are given to you. And then let's go through this one. The total area represented by the L shape, which is this diagram here, below is 21 units. Total area represented is 21 units squared. And the equation y minus 2x is equals to minus 7. That is the equation which represents the relationship of the sides of the two squares. Okay, grade 12, and then they now say solve for x and y, dimensions of the two squares, which is the dimensions of the two squares if y minus 2x is equal to minus 7, and the x squared plus xy plus y squared equal to minus 1. Therefore, now we are having our equation 1 there, and then we will say this is our equation 2. Okay, now you know the method, grade 12, that we need to compare the two equations. Take the linear one. As you can see, this is the linear one with the x to the power 1. And then create your equation 3 from the easy one. So now we are creating equation 3 from 1. So we are going to transpose the minus 2 to the right-hand side. So we will be left with y is equal to 2x minus 7. Then this will be our equation 3. And the next step, we are substituting the y value into the equation 2. That means everywhere where you are having a y, we are now going to remove and put what? The 2x plus minus 7. Sorry for that. And then now we are having a y there. You have y there. Those are the two y's that will be substituted. Let's continue. Okay, let's do it, grade 12. We are having x squared plus x from equation 2. And then for y, we are now substituting the 2x minus 7. Okay, and then we have a plus. And then for y squared, we substitute also y with minus 2x minus 7. Remember, this is now all squared. And then I am automatically transposing this 21 to the left. Minus 27 equals to 0. And then as you can see now, we are having brackets that we need to deal with. And then now we have x squared. Remove the brackets. It's x times 2x, which will be plus 2x squared. And then the x multiplied by minus 7, minus 7x. And then plus. For this bracket, grade 12, remember we have a 2 that is blocking everything. We need to deal with this bracket. It simply means you are multiplying two brackets of 2x minus 7. Or you can use the short method of square the first term. That will be 4x squared. Multiply the first by the second. That will be minus 14x. Multiply by 2. That is minus 28x. And then square the last term, which is minus 7 squared. That will give us a plus 49. And then we bring down the minus 27. That is equals to 0. And then from here, grade 12, now you can see now normal bracket. And then the next step, we will be looking at the common or like terms. Let's see now. We have x squared plus 2x squared plus the 4x squared. And then this is now giving us how much? The 7x squared. And then another like terms, we are having minus 7x and then minus 28, which is giving us what now? The minus 35x. Lastly, we are having 49 minus the, oh, that is 21, sorry, grade 12, sorry, this is 21, not 27, sorry for that. And then it's 49 minus 21, which is giving us a 28, equals to 0 there. Okay, remember you can use your quadratic formula if you want, and then if you are not that comfortable with the short way of finding factors. For those who are comfortable, or we can just go quadratic then, grade 12. That is x is equal to minus b plus minus the square root of b squared minus 4ac over 2a. That will be minus 35 from the b value there. And then plus minus still b minus 35 squared. And then we have a minus 4. And the a value 7. That will be 7 there, and the c value plus 28. And then everything over 2, the a value 7. So we end up with the x value, which is equal to 4, or another x value equals to 1. Even for those who are going to use the short way of factorization, we'll end up with the same values. And then grade 12, after finding the x values, remember we are solving for both x and y simultaneously. Up to this far, we have just calculated the x values. Now going forward, you also need to find the y values. And then going back, checking in our equation, we have that equation, that one, and the third one that we have created. You can see that the easiest one to use to find the value of y is the third equation, because it is automatically saying y is equal to. Let's make our life easier. We are taking the y equal to. So where we are having an x, we are going to substitute our x, first x value, which is 4. And then that will be 2 into 4 minus 7. Or secondly, we are going to substitute the x with 1. 2 into 1 minus 7. So we end up with y equals to 1 for this one, and then the y equals to minus 5 for that one. And then let's look at our solution creatures. Are they all applicable? Because if we talk x and y, we are talking to values of the sides according to the diagram. Always relate your solution to the diagram, whether are they valid or not. And then when you look at this, we are having a y that is -5. Can a side be -5? No. Therefore, we are going to cancel this as being not the solution for this particular question. And therefore, those will be the remaining values that are applicable for these simultaneous equations. Hoping that we are still together. Grade 12. I am taking another simultaneous, but this one has to do with the complex numbers. I have clustered together because we are solving for both two unknowns, like in simultaneous equation. Slightly almost the same application. Number 1, solve for k and m. So you identify the variables that you must solve. As you can see here, we are looking for k and m, grade 12. So as you decide with your moving of items, whether to the left or to the right, please ensure that the k and m are on the same side, because those are the ones that you are looking for. All right, let's start now. This is the equation given to us. So k is already on the left-hand side. Happy now. We are going to take that 2mi to the left-hand side, which will be minus 2mi. And then on the right-hand side, we are left with now 6. Let's remove the bracket automatically. That will be plus 4i, and then the minus 36 then. All right. And then you can see that we are having like terms on the right. Let's deal with that. We are having k minus 2mi. On the left, right-hand side, we are having the 4i. And then 6 minus 30 will be, minus 36 will be minus 30. And then that is 4i. Look at me. I am arranging this according to the pattern on the left-hand side. As you can see that my I item is the second one. Hence, I am putting 4y to be the second there. Okay, after rearranging in that format now, I can now relate what is going on. I can see that the k is having a relationship with minus 30, minus 2mi is having a relationship with 4y. Therefore, my conclusion will be that k is equal to minus 30, and then the next one for minus 2mi, it will be the 4i. So we are looking for the value of m. As we can see that the minus 2m is equals to 4. Then m will be equal to 4 divided by minus 4, which is the minus 2. Basically, grade 12, that is how you solve the complex numbers in relation to simultaneous equations. Let's continue. Moving forward, we are done with the simultaneous. We are still on algebra, grade 12. Remember, we said the algebra is carrying 50 plus minus. And then now let's look at the question 6. Two alternating current circuits connected in series have an impedances. Z1 is 4 plus 5i, and Z2 is minus 4 minus 4i. The total impedance is ZT with that particular formula given to us equal to Z1 plus Z2. So now here is straight and forward. You just have to calculate the total impedance, which is ZT. All right. The impedance ZT is equal to the Z1 plus Z2 as given to us there in the equation. So yours is just to take the given values and plug them in. Z1 is 4 plus 5i substituted, and then Z2 is minus 4 minus 4i. So we are just adding those two. The 4 minus 4 will give us a 0, and then the 5i minus 4i will give us a plus 1i. And then now grade 12, remember this answer is now in rectangular form. If we want to look for the value of A, we can see that our A value is 0, and then the B value here is 1. Okay, so that is in rectangular form. Moving forward, 6.2, hence express the total impedance in the form of Z1 is equal to R into cos theta plus I sin theta. Show all your calculations. Number one, grade 12, you need to understand that this is now in what? In a polar form. And then now you need to show all your calculations. How are you going to change the previous one? Since the question says hence, remember previous we have a total impedance being 0 plus 1i. And then we want to change this now to polar form. Okay, let me give you 1 minute, grade 12, and try to find it for yourself. And then from there we will discuss the solution. Only 1 minute. Okay, grade 12, let's now check how far did you go with this one. Okay, remember now, if we are changing a rectangular form to polar form, we always look for the argument, which is theta in mathematics, you know that, and then also r, which is the modulus, and then for r we are using Pythagoras. And then with the tangent, with the theta we use tangent, tan theta is equal to the b over a. And then let's check, can it work for us on this one? We are having a tan of theta, and then if you leave theta there, this will be arctan of what? B is equals to 1, and then denominator 0. And then if you put this into your calculator, it will say an error, because mathematically we are not allowed to divide with a 0. Okay, grade 12, but this does not mean that we do not have a solution for this one. This simply means now our angle lies on one of the Cartesian plane lines. Okay, let's predict what is happening now by putting this in the Argand diagram. That will assist you a lot. The minute you get something that doesn't make sense to you, put the given information, your rectangular form, in an Argand diagram. Let's see now. Our Argand will be like this. Look at that. This is the A value, and then this one is the B value. Remember, the A value is representing X, or the real axis, And then the B value is representing what we call y-axis in functions. And then here in complex numbers, we call it the imaginary axis. Okay, that simply means now x is 0 and then the y is 1. So we are having x 0 and then y will be 1 there. That means the Eigen diagram of this will be lying on top of the 90 degrees line. So this is automatically telling us that our theta value will be equals to 90 degrees. So grade 12, you make use of that Eigen diagram. It will help you to identify the value of your argument. Now, let's look at the modulus and see how far did you go. Remember, the modulus is the R equal to, using the same Pythagoras theorem that we are used to. And then now we are having the A squared plus B squared, substituting the value of A, which is 0, and the value of B, that is 1. So we will end up with R equals to 1 there. So now our polar notation here will be Z equal to, we were given as R cos theta plus I sin theta. That is our original polar form. So let's substitute the values now. We are having R1, and that will be cos of 90 degrees, plus I, the sine of 90 degrees. You are more than welcome, grade 12, to leave it there, or you can write it in another notation. This can also, remember, be 1 6 90 degrees, also acceptable. The third notation, which is the last one, this can be written as 1, and then that block with the 90 degrees there. Those are 1, 2, 3 applicable notations that we can use on that one. Okay, thank you, grade 12. The next one, moving to question 7. Back to logs now. Look at the logs. That means logs can be asked as in equations, because previously we were looking at the equations. Now it's just the simplification of logs, where we are simplifying without using a calculator, grade 12. We've already done something like this. It's only that this one is not an equation, but it's an expression. Same application. You can have your log of 3 plus 27 is 3 to the power 3. Then this can be 3 log 3 over 81 is 3 to the power 4. And then this can be 4 log 3 minus 9 is 3 to the power 2. Then that will be 2 log 3. And then now you can add your logs, as you are having 1 log plus 3 logs, which will be 4 log 3s. And then 4 minus 2 log 3, that will give us a 2 log 3. So the log 3 will cancel a log 3, so we only end up with the 4 over 2, which is equal to 2. Remember, there are so many alternative things that you can do around that one. One learner can decide to take out the common log 3 here on top and be left with 1 plus 3. And then numerator, again, take out log 3 as being common. And then that particular learner will also end up with a 4 minus 2. And then the log 3 will cancel log 3. So on top, we are having 1 plus 3, which is 4. And then the 4 minus 2, which is 2. So 4 over 2, still 2. So you still have the same answer. The third learner may decide to apply the addition. You multiply the rule. That is saying when you add the logs, you multiply. When you subtract, you divide. So let's apply that one. It will be our last alternative. That will be log 3. Because we are adding, it will be multiplied by 27 on top. Below, it will be a log of 81. And then divide by 9 because we are subtracting. And then this is basically giving us the log of 81 numerator, and then denominator we are having the log of 9. And then we know that 81 can be written as 9 to the power 2. So this will give us 2 log 9 over the log of 9. So log 9, answer 2. So we basically end up with the same answers. Okay, so this is emphasizing that logs both in equations and expressions. Simplify without using the calculator, without using a calculator, grade 12. So when you are on this question, do not touch your calculator at all. I don't want to see any decimals. You just simplify without. Let's see, how do we do that? Number 1, look at the problem and identify. You can see that you are having something in common there that is appearing throughout as 2 to the power n. That will be our starting point. So now we are going to take out that 2 to the power n, which is common. And then if you take that out, we are now left with the square root of 32. Identify 2 numbers that you can multiply, and then one of them must have a square root. So which are those? That is 16 times 2. Because the square root of 16 is equals to 4. And then now moving forward, we have a plus. Here we have a square root 2. We can't do anything about square root 2. It is like that. Divide by, we are having 2 to the power n, which is out because it's common. So we are supposed to be left with square root 50. With square root 50, again, we are applying the same method. Look for 2 numbers. When you multiply them, they give you 50. One of the numbers must have a square root. So now we end up with what? The square root of 25 multiplied by 2. Since the square root of 25 is 5. I am doing this without a calculator. Okay. Basically, you can see that the common factors will cancel out, and then we are left with the root signs only. So the one that is having the square root, which is square root 16, will be out because we know the square root of 16 is 4. So what is left in the root sign? It will be 2, square root 2. And then another square root 2, we take it down as it is. So with the square root 25, we know square root of 25 is 5. And then we will be left with square root 2. Happy now, grade 12. So at this level, we are having 2 ways of doing it. You can say 4 square root 2 plus the square root 2 is 5 square root 2. Divide by the 5 square root 2. Look at that. This is giving us 1. Or basically from that point, you can decide to take out the common square root 2 from this. And then you are left with 4 plus 1. On the denominator, square root 2 out, left with 5. So the square root 2 will cancel square root 2. 4 plus 1 is 5 over 5, still giving us a 1 as a final answer there. So that is what is expected from us from that particular question. Okay. To the next question, we are now looking at the nature of roots. Almost done with algebra grade 12. And then here we are given the 3x squared plus 2x plus 2 equal to, that is a quadratic equation, as you can see that. And then they say determine the numerical value of the discriminant of the equation. All right, you only determine discriminant for 8.1. Okay, 8.1. The formula for discriminant, we know that this will be b squared minus 4ac. That is taken from your quadratic formula below the square root sign. All right. Right. And then now we know that the first will be A, and the second value there is B, and the last one is C. Let's substitute grade 12. The value of B is equals to 2 squared minus 4. The value of A is 3. The value of C, 2 from our equation. And then now, let's check what is the discriminant for this problem. You can just put this in your calculator, then it will give you a minus 20. And then it is showing that the discriminant is now less than 0, but they said determine the discriminant only in 8.1. And then 8.2, it says hence. Remember, hence, use the previous solution to answer this one. Describe the nature of roots of the equation. As we have indicated, grade 12, that our discriminant is negative, therefore it is less than 0. And we know that the classification of roots, if the discriminant is less than 0, therefore the roots are what? Are non-real, or they are the imaginary roots. Okay, right, let's move on to the next question, still on nature of roots. All right, we are given that equation. Now the difference is that this one is now having x and p as being variables there, and then it is given that x squared minus 2px is equal to the 3p squared, where p is an element of real numbers. And then 9.1, we need to write this equation in the original form of quadratic, which is ax squared plus bx plus c equals to 0. Let's do so, grade 12. We are having 9.1, and then our equation is x squared minus 2px equal to 3p squared as given. Okay, and then now if we are writing in this format, here px squared is already at the correct position on the left, so just bring that down. The next term must be the bx, the one with an x is already at the correct position there. Ours is just to transpose the 3p squared to the left, so this will be minus 3p squared equals to 0. And then if you look at this equation now, is in that required format, hence it is only 1 mark. And then the 9.2, the hence question again. Okay, without solving the equation, show that the roots of the equation are rational. Grade 12, if they say without solving, they mean without factorizing the equation. But to show that the roots of this are rational, we still depending on the calculation of what? The discriminant. That is the one that will tell us whether the roots are rational or not. And in this case, we are showing. When you show, you don't conclude, you prove to us. So we cannot say the discriminant is greater than when we start, because it's what we need to prove. So we'll just take the discriminant and check after substituting and simplifying what type of roots are we going to have. Okay, using the equation above. Let's substitute. The value of p is minus 2p. Remember, you need to take the coefficient of x. In this case, is having a variable p. We are going to take it as it is, which is minus 2p. And then remember, this is squared. Minus 4. The a value is 1. And then the c value, again, we are going to take everything. We treat this as being a constant because there is no x on that one. So therefore, this will be minus 3p squared. Let's check now. What are we having? Minus 2p squared will end up with 4p squared. And then minus 4 times 1, that will be minus 4. Minus 4 times minus 3 is positive 12p squared. And then the 4p squared plus the 12p squared is giving us the 16p squared. Okay, grade 12. Remember that the 16 is the same as 4 squared. Can you see those are square numbers? Those are perfect squares. It's 4p squared. And then since it's a perfect square, remember, if the answer will always be positive. If you square any number, your answer will be positive. Doesn't matter whether it's a negative or a positive number. Eventually, when you square, it will be positive. That means this concludes that our discriminant in this case will always be positive. And then since it is having a square, therefore it is what? A perfect square. And then if that is the case, therefore our roots are what? Are rational. Out of being perfect, we can conclude that. All right. Right, we are done with the first topic, grade 12's algebra. Those are the basically expected types of questions that will be on your algebra. And then now let's move on to the next one, which is functions and graph. This is carrying 35 plus minus 3. Okay, we are given function K and function Q. Function K, function Q, and defined by those equations. Number one, grade 12, it is very important to know your types of functions. By just looking at the first equation, you must be able to identify this is a parabola graph or a quadratic function. And then by just looking at the equation, you must be able to predict that this one is a hyperbola graph. Okay, know your original equations, grade 12. And then now let's look at the questions. 10.1, write down x-intercept of k. And you must be careful, grade 12, as you are answering such questions where you are given two equations, because it is talking to a specific graph. Like this one, it says write down the x-intercept of k. That means we are looking for the x-intercept, but from which function? From the k function. Therefore, 10.1, let's ensure that we select correctly. So the k at x is equal to x minus 5 and x plus 3. That is the equation we are referring to. So if we calculate the x-intercept, we let y equal to 0. And therefore, the y side will be 0. So we have x minus 5 and x plus 3, which give us what? X equals to 5, or the x is equal to negative 3. Those will be the x-intercept for that parabola function. 10.2, determine the coordinates of the turning point of k. We are still on what? On the parabola graph, because it's the one that is having the turning point. But grade 12, remember, we have three ways of finding the turning point of a parabola function. Number one, we can use the same x-intercept that are given to us as being 5 and minus 3. Let's start with that one and check the midpoint of x. So that will be x mid. It will be x2 plus x1 divided by 2. That is your analytical geometry midpoint. All right. So our x2 is minus 3 plus 5, x1 divided by 2. And then this will be basically 1. Okay. If another learner decided maybe to go x equal to minus b over 2a method, that means you need first to multiply the brackets out. And then let's do so. That will be k at x. Multiplying out will be x squared. X times x, and the x times 3, that will be plus 3x, minus 5 times x, minus 5x, minus 5 times 3, that is minus 15. And then from there now, we can add the middle ones. 3 minus 5x is minus 2x, minus 15. And then after having the quadratic equation, you can now look at x is equal to minus b over 2a, and then now substitute the value of b, which is minus 2. That will be minus 2 over 2. Our a value is 1 there. That will be 2 into 1. So this is giving us 2 over 2, which is still 1. Can you see? We are getting the same x turning point value. The last method of doing it is using the calculus method. All right, with the calculus, you need to derive. That means you still need to multiply out the bracket and end up with the equation x squared minus 2x minus 15. And then from that, now you can derive this. Okay, derivative of x is equal to the 2x minus 2. And then you know that when you are looking at the turning point calculus, you let the derivative be equals to 0. And then we have 2x minus 2 still on the right-hand side. Transposing a minus 2, left with 2x equals to 2. Divide by 2 both sides. Therefore, x is equals to 1. So can you see grade 12? We end up with the same x values throughout. All right. We applied 3 different methods. But remember, we are looking at the coordinates of the turning point. Up to this far, we have just calculated the x value. We still have to do what? Calculate the y value for that. For the y value also, we are having 2 ways of doing it. The first one is to take the x value and substitute into the original equation. What is our original equation? Is the k at x equal to x minus 5 into the x plus 3. And then this will be k into 1. Where we are having an x, we now substitute a 1. A 1 from where? From the x turning point. And that will be 1 plus 3. And then this gives us the value of y being minus 16. Okay. Grade 12, if you don't use that, at the back of your formula sheet, we are having a formula for the y turning point. You can even use that formula. It states that y is equal to 4ac minus b squared over 4a. We can just substitute in there using the same equation that we have multiplied out. That will be 4. Our a value is 1. The c value minus 15 minus, let's see, the b value from there minus 2 squared over 4 a value 1 from there, that is what. So also this one will give us a minus 16. Therefore, our turning point will be 1 and minus 16. So those are the different ways of finding the turning point. Continuing with the same question, 10.3. Determine the x-intercept of Q. Write down the equation of the asymptote. Determine the equation of axis of symmetry of Q, I think. It was supposed to be of Q. And then 10.3, let's see now. Determine x-intercept of Q. Q, remember, is a hyperbola function. And then when you look for the x, we let y equal to 0. Same method, grade 12. 10.3, y is 0. And then we have 12 over x minus 2. Transpose to positive 2. Then we have fraction 12 over x. We can now cross multiply this, x to 2. Then we end up with 2x equal to 12. Therefore, divide by 2 both sides. Therefore, x is equals to 6. That is the x-intercept of that function. And then 10.4. Determine the equation, or write down the equation of the asymptotes of Q. Okay, Q, we are still referring to the hyperbola. Grade 12, with your hyperbola, technical mathematicians, the x asymptote will always be x equal to 0. Your hyperbola graph is not shifting left and right. It will always be equal to 0. And then yours is just to check what is the asymptote for the y asymptote, which is y equal to minus 2, determined from the equation part, that one. And then the 10.5, determine the equation of the axis of symmetry of Q then, all right? And then now remember, axis of symmetry, I have in 2 equations. Originally, that is y is equal to x plus c, or the y is equal to minus x plus c. The gradient of the lines will always be given to you as 1 and minus 1. For you, it is very easy, technical mathematician. The c value will always take the q value from your equation there. Then the equation, first one, axis of symmetry will be x minus 2, or second one will be y equal to minus x minus 2. That's it, grade 12. That is how you determine those 2 equations. Don't stress about calculating and do so many calculations. Just take your q value and plug it in those original equations of the axis of symmetry. And now we need to sketch those graphs. Okay, let's look at the values now. Okay, for the k at x function, we are having the x-intercept, which is x equal to 5, and x equal to minus 3. And then if we look at the turning point, you have already calculated previously as 1 and minus 16. And then the y-intercept of that graph will be y equal to minus 15. And then with the q at x function, let's look at this. We need the asymptote that will be x equal to 0 and the y equal to minus 2. We have already calculated that grade 12 previously. And then we need the intercept, which is the x-intercept of the function. And then we have already calculated that x is equal to 6 from our previous calculations. And then grade 12, for this one, we are not going to calculate the y-intercept for all your hyperbola function. Because if you calculate, let's see what is happening. You have y is equal to 12 over x minus 2. Remember, when you look at the y-intercept, you let x equal to 0. Look at that now. 0 is on the denominator, and we know mathematically division by 0 is not allowed. That means for all your hyperbola function, they will never cut the y line. We will never have a point on the y-axis. We are depending on the x-intercept and the asymptote to sketch that particular function. Let's predict the sketch now, grade 12, together with you. There you are. Okay, let's start with the parabola one. It is having x5 there. And then we have a minus 3 as our x-intercept. And then we have minus 15 as our y-intercept. Easy, we can just join them. Our turning point is 1 and minus 16. Turning point minus 16 there. So it is coordinating to that point. So we have that one. We have the y-intercept, our x-intercept there. Then we join them together. This is the graph we are talking to of a parabola 1, which is k at x. With the q at x, now we are talking hyperbola. Now, when you sketch a hyperbola function, always start with the asymptote. Always start with the asymptote. So we are having an asymptote x equal to 0. So the x equal to 0 is the y-axis line. So we are going to have an asymptote which is on top of your axis there. And then now another asymptote now will be at y equal to minus 2. Negative 2 there, we have an asymptote there. Those are the asymptote for the hyperbola function. And then it is cutting at x equal to 6. We have a point there, x is equal to 6. And then grade 12, if you look at your equation now, the value of a here is greater than 0, meaning it is positive. That simply means now we are expecting the shape of the graph to be in quadrant 1 and 3, which is controlled by the asymptotes there. And then now this simply means our line will be close to the asymptote, cutting at x, going down to close to the asymptote. That will be our first arm. Then the second one will be just a free arm going on that particular quadrant. Basically, that is what is expected of us in terms of sketching. Let's continue still on functions. Question 11. Sketched below are the graphs of P and H, defined by P at x is equal to minus r squared minus x squared. Grade 12, remember I said to you, you must be able to predict the types of graphs that we are having through their equations. So this one you can see is a circle one. Therefore, it will represent the semicircle that you see on the diagram. And then you are having h at x is equal to a to the power x plus d. Therefore, that one will be the exponential. Okay, this one is a circle one. That will be an exponential one. The semicircle, half circle. And then respectively, T is the point of intersection. Look at T. Let's analyze the diagram. T is the point of intersection. And then A is -1, -2. As we are reading through the statement, we check is everything now indicated on the diagram. So if A -1 and -2 is a point on H, the asymptote of H is indicated by a dotted line. There you have it as y equal to -4. Now, the question states, write down. They don't say calculate, you just write down. That means your answer is there somewhere, okay? Write down the numerical value of D. What is D? D is the Q value for the exponential function. And remember, this D is now representing what? The asymptote. Therefore, the value of D is equal to -4. Where do we get that? From the asymptote equation that is given to us. That is why the question states right, because the answer is there. And then show that h at x will be equal to half x to the power x minus 4. Remember, initially the h at x was given as a to the power x plus d. Okay, and then now we have a point. You identify the equation is an exponential. We go to the exponential graph and check. We are having a point there, which is -1 and -2. So grade 12, we are relying on that point A, -1 and -2. That will be used as x and y substitution in our equation so that we can determine the value of A. All right. D, we have already identified that D is -4 from the previous question. So for h at x, since it is y, we are going to substitute a -2. And then we have A for x, we are going to substitute -1. D from the previous question, it is already -4, which is from the asymptote. Okay, grade 12. And then I am transposing -4 to the left-hand side. It will be a +4. And then 4 minus 2 is giving me a 2. Then I'm having 1 over A. And then that will be cross multiplication again. That will be 2A equals to 1. And therefore my A will be 1 over 2. Now I am taking all the information back to the equation. That is h at x is equal to, the A value is now half, calculated there, to the power x, and then the D value is -4. Therefore, we have proven what was expected from us. In all the functions, grade 12, if you are given a point, use that to your benefit as your x and y value, okay, to determine the equation of any function. All right, hence determine the coordinates of T. It is saying hence determine the coordinate. If it says hence, it says take the equation h at x from the previous question, the one that we have just identified, that is half x minus 4, to find the value of T. Where is T? T is the y-intercept of both the circle and the exponential. But we are avoiding using the circle because we don't know the values of the circle. We can now rely on the exponential one since we know the actual equation of that graph. Okay. And then we have now identified that T is what? Is the y-intercept. Therefore, we'll be looking at the y-intercept of that function when x is what? Equal to 0. So now y will be equal to half, substitution 0 minus 4. And then this is taking us to what? A -3. Therefore, coordinates of T will be x0 coordinating with a -3. Okay, so the next question, 11.4. This was 11.3, 11.4. Write down the range of P. If we are arranging grade 12, we are talking to the Y values. So we talk of the Y. So our focus will be on the Y axis, all right? And then range of which graph? P. Be careful, ne? Read your questions thoroughly and check the question is talking to which function, especially when you are given two graphs. Because grade 12, remember, you'll be writing for 3 hours. Sometimes you end up taking incorrect functions. Read and check the question is talking to which specific graph. So in this case, we are talking to P. Okay, that means that semicircle graph. Remember, we have just identified that this point here is 0 and minus 3. So, and if you look at this, this is the radius of the semicircle, it's 3 units. Remember, the radius is the same throughout. This simply concludes that this is also 3 there. Going this way again, this is also a minus 3. So if you want to check the range for this, you can see that this graph ends there. It starts from T, therefore it is ranging between these two numbers. The minute we say between, that means our Y will also be in between. Starting with a smaller number this side, starting from minus 3, stopping at 0. And these are part of the graph. So we are also including that minus 3 and 0 by the indication of an equal sign. And then if you don't note them like that, you have another notation. You can write them as Y is an element of, because it is included, you are going to use a square bracket, start with the smaller number, minus 3, coordinating with the 0, and then also close bracket because 0 is also part of that particular solution. Hope grade 12, we are still together. Moving forward, it is still a hence question. So it says, hence determine the defining equation of W at X of function W such that the W is the reflection of P on the X-axis. And then when you look at the previous question, what is P? P is the equation of the semicircle. It was initially given to us as P at X is equal to minus the square root of R squared minus X squared. And then if we write this with the value of R, remember we have just indicated that the radius of that circle is 3, which is determined from the point T, 0 and minus 3. So now if R is equals to 3, therefore R squared will be equals to 9. And then now we are now substituting this 9 in the place of R squared, and then we have our semicircle equation. And grade 12, do not be confused by the shape of the circle. If it is negative, look at it, it will cut on the negative Y values. Do not confuse this with the concave up, concave down of a parabola function. They do not act the same. If it is negative, the semicircle will cut on the negative side, Y value. And then if it is a positive one, semicircle will cut. Same way if it's a X1 and the X positive there, okay? So those are the shapes of the semicircles. Never confuse this with the parabola one. Go back to our question. We are looking at the reflection of the P. We are reflecting P along the what? The X-axis. Remember, basically grade 12, if I am reflecting a number, let's say I'm having 1 and 2 here, and I am reflecting this along the X-axis, this will appear as if it is somewhere there. Let's look at the impact now. The distance is still the same, 1 and 2, but look at the Y value now. Our Y values this side are negative. So this 2, instead of being positive, it will be a negative 2. So if I am reflecting along X, X is in charge. As you can see that X is not changing, but the negative impact will be on the Y value. Back to our question. We are reflecting P along what? The X-axis. So X is in charge. It will never gain anything. What is going to have an impact is the Y, which will gain a negative. So eventually we end up with the Y multiplying throughout with the negative square root of 9 minus x squared. Therefore, this is our WX equation, which is reflected about the x-axis from the equation of P at X. Okay, moving forward. Okay, we are having a financial math equation, grade 12. Let's take 1 minute. Tato invests 250,000 on her savings. She is quoted a nominal is 250, nominal interest rate 7.4. It is compounded monthly. Calculate the equivalent effective annual interest rate. Correct to what? To 2 decimal places. 1 minute, grade 12, hit on. Okay, grade 12. Let's check now how far did you go with this one. Remember the formula for the effective rate, it will be on your formula sheet. It is already there. And then what does the formula state now? It says that the I effective will be equal to bracket 1 plus I nominal over the compoundment to the power compoundment minus 1. And then let's substitute now. It's 1 plus I nominal is given there. That is 7.4%. Compounded monthly divided by 12. Same value here and there. Okay. And then minus 1. Everything into your calculator, grade 12. This will give you 0.0765 and so on. And then now remember, we need to take this to the effective rate. You multiply that by 100. That means you will end up with, that will be 0.0765, continuing multiply by 100. Then this will take us to 7.66%. Okay. You must be able to do that, grade 12. All right. 12.2. Still on the same question now. Calculate how long in completed month. How long? You must know the language of financial mathematics now. The minute we say how long, we are looking for the value of what? The value of n. And then our answer must be what? Completed in month. Give your answer in month, not years. Okay? That will take Tato's investment to grow to at least what? 300,000. Initial investment was 250,000. And then this is now growing to what? To 300,000. So since it's an investment, grade 12, therefore we are going to use the formula A is equal to P into 1 plus I to the power n. All right. And therefore, remember, we have identified that this is our I value. And then this is the one that is invested. Therefore, it's a P value there. And then this will be the amount that he will get at the end of the investment. And then now we have everything that we need. Let's substitute. Okay. We have A, that is 300,000. And the P value, initial invested value, 250,000. 1 plus the rate of 7.4%. compounded monthly, you need to compound that, okay? For n, we are not compounding. We were supposed to also compound n to 12. And remember, when you compound your rate, you also compound the n. But if you compound n, it will give you your answer in years. Since in this case, they said in months, we don't compound n because we want it in months as it is. So leave it like that. And then grade 12, now we divide both sides. We want to get rid of this 250,000 from the right hand side because eventually we want to end up only with an n there. Okay, we are going to divide both sides by 250,000, and then this is giving us a 1,2 this side. And then when we add this fraction inside the bracket, it is giving us fraction 6037 over the 6,000. And then this is to the power n. And then now you know that in order to take n down, we are now bringing in what? Our logs. Logs will assist us. That is log 1,2 from the left hand side. And then this will go to the base. That will be 6037 over 6000. Grade 12, please avoid rounding off your answers in between your calculations. Work with those fractions until the final answer. It's only then that you can round off. Financial math, round off only at the final solution. Okay, so this will give us an n that is equal to what? 29,7 and so on months. And then therefore, because they indicated that indicate the complete month, therefore n will be equal to how many? 30 months. To the nearest month, 30 months. Okay, moving forward. Another financial math question. A company brought a new 3D wheel alignment machine. And then this machine cost how much? 240,000. The machine depreciated. The value is going down. I'm putting an arrow there to remind me. At the rate of what? 6%. Okay? Per annum to what? To have its original value. This value depreciated goes down to have its original value over a certain period. Okay? So the first question is, give the appreciated value of the machine at the end of the period. Remember grade 12, this machine was costing initially 240,000, right? And then now at the rate of how much? At the rate of 16% per annum, all right? And then this has now depreciated. And then they say give, you are not calculating, eh? We don't need a long calculation there, okay? Give the appreciated value of the machine at the end of the period. So now this will appreciate because it is half of its original value. So half of 240 is how much? 120. Then this will be 120,000. That is all that we need as a solution for that one. And then determine how long it will take for this. Since the formula is depreciating, that will be 1 A equal to P into 1 minus I to the power n. Look at this. This is negative because it's depreciating. Depreciating from which value? Initially it was 240,000. It has now depreciated to 120. We have just determined that on the previous solution. Then this will be 1 minus same rate, 16%, and then to the power n. And then same method, grade 12, we are dividing by 240,000 both sides. We'll have 0,5. And then 1 minus 16% from that one is 0,84. What? To the power n. Bring in the logs. Log 0,5, base 0,84. That is the n value. So n is equals to 3,98. This is approximately how many? 4 years. All right. So grade 12, basically, we are using the same formulas throughout. Let's pass that one, pass this one. Okay, differential calculus. You know that the first one will be on first principle. Yours is only linear one. And then now we have f at x given to us. For us is to identify the f at x plus h. That means where you are having an x, we are now substituting x plus h. That will be 5 minus half. And then we have a x plus h. And then from there, we can now remove the brackets. That will be 5 minus half x minus half h. Go to the first principle formula. F derivative of x of the limit of h approaching 0. Remember the formula says that f at x plus h minus the f at x, grade 12, over h. Remember, double check this formula that it is written correct. Most of the time you forgot that dash there, okay? And then continue with the limit indicated. Notation is very important. Substitute the f at x plus h. That is 5 minus half x minus half h minus what? My f at x. Now, since f at x is having two terms, we need a bracket. That will be 5 minus half x. That bracket is very important, grade 12. And then the limit of h approaching 0. That is 5 minus half x minus half h. Multiply a negative in now. You have minus 5 plus the half x. Everything over h. Let's check grade 12. Immediately after removing this bracket, there must be cancellation. Check from the left. Half x minus half x minus 5, 5. And your whole f at x must be cancelled. If there is no such cancellation, you must know you are going wrong. All right. And then now this is the limit of h approaching 0 of minus half on top h over h. The h will cancel an h. Our answer will just be a negative half. Okay, differential calculus. Question 2, you know that the next question will be on rules. All right. You know our rule, grade 12, is an exponent multiplied by the coefficient and then subtract 1 from the exponent. Right, let's look at the first one now. Taking 16.1. Our f at x equation is this one. This one will be treated as a constant because there is no x on that one. It's like the same way as we are having a 2 and a 4. We know a derivative of a number is 0. All right. So this one will give us the 0. Be careful of the notation also, grade 12. The minute you start deriving, indicate to us I am deriving. So it will be an exponent multiplied by the coefficient minus 0, 5. And then that will give me what? Minus 1,5. And then from the exponent, you need to subtract 1. That will be to the power 2. Negative 1 times negative 1, positive 1. Subtract 1 from the exponent. That will be x to the power negative 2. That is what is expected from your grade 12. And then let's look at 16.2 now. The dx one. We are having dx into x into the square root of x plus 2. Okay, you know that there are those instructions before you derive, no brackets. Before you derive, no root sign in your equation. Before you derive, no variables in your denominator. So here we are challenged. We are having a bracket. We are also having the root sign there. So you need to deal with those two. Notation, grade 12. As long as I am not deriving for this notation, I must continue with the dx. All right. And then now I'm having an x there. And then in bracket, I'm removing that square root, writing it in exponential form half, and then the plus 2. Step number 2, I am now removing the bracket by multiplying them out. Remember, this is x to the power 1. Multiplying the same base, you add exponent. So this will be x to the power what? 3 over 2 plus the 2x. Multiplying x in, and in there. Happy now, this is now linear. We can now derive. Is the exponent time is 1, 3 over 2x, and then you subtract 1 there. That will be x to the power half. Okay, grade 12s. And then if your exponent is 1, just take the coefficient there. That will be 2. Then that is the derivative of that using the rules. And then 17.1, we are taking this equation now, and then we make y the subject of the formula. So now leave out xy, take 2x to this side, it will be 7x to the power 6 minus the 2x to the power 3. Look at this, grade 12, we need only y, then you are going to divide throughout by what? By x. Okay, so we are left with y, the one that we need, and then this will be equal to what? X into x to the power 6 will be 7 to the power 7x to the power 5, and then the minus 2x to the power of 2. Okay, that was the first expected answer. 7.2, hence now determine the dy dx. Derive y in terms of x. So dy dx of this one will be 5 times 7, which is 35. X subtract 1 to the power 4. Okay, and then minus 2 times 2, that is minus 4. And then x to the power, you subtract 1 there, that will be x to the power 1. Just like that, grade 12. Application of the rules of calculus. The equation of a tangent to the curve, question 18. The equation of a tangent to the curve of a function g defined by g at x is g at x equal to ax squared minus x. And then the equation of that tangent is what? 3x minus y plus 2. And then the point of contact of the tangent and the curve g is minus 1 and minus 1. Determine the numerical value of what? Of a. Okay, grade 12, you know that the tangent is having a relationship with the cubic function. Okay, it's having a relationship with any function that is have a point of contact with. So when we talk the gradient of a tangent to a certain curve, we are talking the derivative of that particular curve. That means in this case now there is a relationship between a gradient of a tangent and the derivative of a particular curve that is attached to. And then now let's start by identifying the gradient of this particular tangent line. The given equation is 3x minus y plus 2 equal to 0. And then we leave 3x this side, we take y to that side. We can see that the gradient of that tangent is equal to 3, determined from the equation. And then now we relate this to the g function that is given to us, of which it is a tangent to g at x is equal to ax squared minus x. We know that the derivative of this function, which is 2 times 1 is 2ax, and then the minus 1 from there. That is the derivative of that particular function. And we said the m of a tangent is the same as the derivative of the particular function that is have a point of contact sharing. So it simply means this 3 will be substituted for the g derivative, which is equal to 2a. Remember, we are given that this is having a point of contact at x equal to minus 1. So we'll put a minus 1 on x, and we have that. So negative 1 to the side, it will be 3 plus 1, that will be 4. So negative 2a on the right-hand side. Divided by negative 2, a will be a minus 2. So we were expected to determine the numerical value of what? Of a. And then given that function, differential calculus, write down the one write down. The minute it says write down, no calculations. That means your answers are there. So with 19.1, what is the y-intercept of this? Look at that equation. It is given in the two format ways. That is very easy for us, grade 12. If you put a 0, 0 there, because when you look at the y-intercept, you let x equal to 0, you can see that your y-intercept will be only minus 3. 19.2, determine the x-intercept of f. Very easy for this one. They are already given to us. We only let y equal to 0, and then we'll be having minus x minus 1 already factorized for us. Therefore, x is equal to 1 or x equal to minus 3. Okay. All right, grade 12. Determine the coordinates of the turning point. Turning point, remember, we did it previously on the parabola one, that when we are talking turning point, we are talking the derivative of a function. All right. And then we are now going to look at the stationary point of this one. Turning point is the stationary. So we derive f at x, relying on this part of the equation. That will be minus 3x squared minus 2x plus a 5. After deriving, we let it equal to 0. And then we can now factorize x equal to minus b plus minus the square root of b squared minus 4ac. Remember, quadratic equation will help us through. It's a minus 2 plus minus b the same b minus 2 squared minus 4, the a value minus 3, the c value 5, 2 over minus 3. And then let's check now our first x value will be equals to 1, or another x value will be equal to minus 1,67. Okay, and then now when you want the y value, same way, you substitute 1 into this or that equation. So by putting 1 there, you can see that it will give you y value 0. And then we substitute minus 1,6 in either of the equation. We will end up with minus 9,48 grade 12. And then now we will be having two turning points. The first turning point is 1 and 0. The second one is minus 1,67, goes with minus 9,48. And then grade 12, you must be able to tell which one is the maximum one turning point, which one will be the minimum. Since this graph is a negative 1, we are going to have something like this in terms of shape. Then therefore, this one will be maximum turning point. This will be the minimum turning point. So you must be able to identify which turning point goes with maximum, which one goes with the minimum turning point. How do you do that? You compare the x values, the y values of the turning point. As you can see that 0 is greater than minus 9. That means this one will be the maximum turning point. And then this one will be the minimum turning point. Okay, and then now grade 12, we now sketch the graph, clearly showing all the values that we have identified on the previous calculations that we had with you. We had y-intercept being minus 3, and then we have the x-intercept being 1 and minus 3 from the previous one. And then we have the turning point at 1 and 0, and we have indicated this one is the maximum one. That is why we are having that curve there. And then we have another turning point at minus 1,67, coordinating with minus 9,48. And then we said this one will be the minimum turning point. So this turning point, they are now giving you the direction of how will your curve look like. Therefore, this is the graph we are expecting, grade 12. And then now lastly, okay, that determine the values of x for which the derivative of this function is greater than 0. To identify the derivative, grade 12, we are relying on If you look at this part of the graph, this side, it is decreasing. Moving from left to right, you can see the graph is going down. So the minute it decreases, the gradient is negative, less than 0. So this part, it is going up, it is increasing. So the gradient will be greater than 0, meaning positive. Again, decrease this side, therefore the gradient will be less than 0, which is negative. Now we want to identify where the gradient is greater than 0. Greater than 0 means where it is positive. So that means we are relying on which part, grade 12, which is this one. Okay, so if you look at that part, it is between the what? Our stationary point minus 1,67, because we are identifying that in terms of x, between minus 1,67 and 1. And then we are not including those values because they are stationary at that point, not positive, not negative. Okay, let's pass these ones. I want us to look at the differential integration a little bit. Let's take the integration now. Moving on to integration, determine the integral of 2 to the power x, and then we know grade 12, if your x is on the exponent, that means your integral will be a ln now. So we are having a 23,1 there, 23.1, question 23.1. So if we want an integral of that, that will be integral of 2 to the power x dx. This is equal to what? The x on the exponent ln 2. Remember, you must add a plus c. You have the rules on the formula sheet that will assist you to identify which rule to apply there. And then let's look at 23.2. For this one, you need to divide each of this term with the denominator x to the power minus 1 before you can apply your integration rule. So x to the power minus 3 over x to the power minus 1, that will be x to the power minus 2. X squared over x to the power minus, that will be x to the power. Remember, dividing the same base, you add exponent, right? That will be 2 minus, grade 12, we are having x to the power minus 3 for the first one over x to the power minus 1. If you are dividing the same base, remember minus 1, when it goes there, it changes the sign. You subtract the exponent. That is why we have a minus 2 there. Same applies. The next one, you are having the x squared divided by x to the power minus 1. And then that will be 2 minus minus 1, which is x to the power of 3. And then with the minus 2, 1, there is an x to the power 0 there. And then remember, we have not yet integrated. We still write that dx. And then now everything is in order. We can now integrate. We can now integrate. With the integration now, remember, is that click of plus 1, all right? That means we'll be having x to the power minus 2 plus 1. And then minus 2 plus 1 is negative 1. It also goes to the denominator. And then plus x to the power 3 plus 1. And then it gives us a 4 of also that 4 goes to the denominator. Minus 2x to the power 0 plus 1. And then that plus 1 also goes to the denominator. And then the plus c for the constant. So this is giving us now a positive divided by negative, which is negative x to the power what? Negative 1. And then now we are having a plus x to the power 4 over 4. Fine with that one. And then this one we are having a minus 2 because it's a negative 2 divided by 1, which is x to the power 1, 0 plus 1, 1. And then the plus c for the constant. Okay, grade 12. This brings us to the end of our session. Okay. I hope what we did together with you today will help us through our exam. Okay, thank you very much. And I'm wishing you all the best. Good luck with your exams. And then I'm having that trophy for all the learners with distinctions. Okay, This was proudly brought to you by the Gauteng Department of Education. Looking forward, grade 12s, to you that at the end of this year, we will be passing that paper 1 with flying colors. Please keep on following the COVID-19 protocols. Always wear your mask, always sanitize, always wash your hands with soap, always keep that social distancing. Keep safe, grade 12. Thank you very much. All the best.